In this lecture, we are going to see the problems related to probability and distributions. First, let's look what is a continuous random variable. A random variable x is said to be continuous if it takes all the possible values between certain limits from real number a to real number b. That means if all the values that the random variable x possesses will be in between, it will have values in between a range or an interval of a to b. If x is a continuous random variable for any x1 and x2, then the following inequalities will hold. That is p of x1 less than or equal to x less than or equal to x2 is equal to p of x1 less than x less than or equal to x2 equal to p of x1 less than or equal to x less than x2 equal to p of x1 less than x less than x2. Probability density function. For a continuous variable x, a probability density function is a function such that the following properties will hold. That is, the function should be always greater than or equal to 0 and integral minus infinity to plus infinity f of x dx is equal to 1. A probability of x greater than or equal to a and x greater than less than or equal to b is equal to integral a to b f of x dx. That is the area under f of x from a to b for any a and b. If these three properties hold, then the function can be termed as a probability density function. And if it is a random variable, the function is called a probability distribution function. And for a continuous variable, it is called as a probability density function. And for a probability density function, it should satisfy the following properties. That is, a function should be always greater than or equal to 0. And the integral from negative infinity to positive infinity of the function should be equal to 1. And the probability when x is greater than or equal to a and x is less than or equal to b is equal to the area under the f of x from the interval a to b for any values of a and b. The mean or expected value for a continuous random variable x. Suppose x is a continuous random variable with a probability density function f of x, then the mean or expected value can be found as integral minus infinity to plus infinity x into f of x dx. This is also represented by the Greek letter mu, and the variance is given as sigma square equal to e of x square minus e of x the whole square. That is expectation of x square minus expectation of x the whole square. We can look into the problems. First problem is a continuous random variable x has a probability distribution function f of x is equal to k and x lies between 0 and k. Determine the constant k as well as find the probability of x less than or equal to 1 by 4. First, we have to find the value of k. We can use the second property, that is integral minus infinity to plus infinity f of x dx is equal to 1. F of x is given as k and integral minus infinity to plus infinity f of x dx is equal to, here the range is given as 0 to k. So it is not k, 0 to 1. Here the range of x varies from 0 to 1. Therefore the integral limits will be 0 to 1. F of x is equal to k. So substituting that k dx. So taking the integral, it will be k into x from the interval 0 to 1. That is equal to k into 1 minus 0. That is equal to k. That is integral f of x dx is equal to integral minus infinity to plus infinity f of x dx is equal to 1. Therefore k equal to 1. So we have found the value of k which is equal to 1. Next, the second part is we have to find the probability p of x less than or equal to 1 by 4. We can use the same property, integral minus infinity to plus infinity f of x dx equal to 1. Here the limits are 0 to 1. Therefore, we can modify the limits integral 0 to 1 f of x dx equal to 1. Here x is less than or equal to 1 by 4. Therefore, the limits can be updated as 0 to 1 by 4. Less than or equal to, since x, the probability of, you have to find the probability of x less than or equal to 1 by 4. Therefore, the limits are from 0 to 1 by 4. And f of x is equal to k. Therefore, k dx. Integral 0 to 1 by 4 k dx. That is equal to k into x from the limits 0 to 1 by 4. That is k into 1 by 4 minus 0. That is k by 4 equal to 1. And substituting the value of k, we get k by 4 equal to 1 by 4, since k is 1. Therefore, the probability of x less than or equal to 1 by 4 is equal to 1 by 4. Next question is, given that the probability distribution function of a random variable x is f of x is equal to kx between 0 and 1, find k and p of x greater than 0.5. To find the value of k, we can use the property integral minus infinity to plus infinity f of x dx equal to 1. Here the range is between 0, x varies between 0 and 1. Therefore, the limits are integral 0 to 1 and f of x is equal to kx. So, it turns out to be integral 0 to 1 kx dx equal to 1. On taking the integral, k into x square by 2 within the limit 0 to 1. That is k by 2 into 1 square minus 0. That is equal to k by 2 equal to 1. Therefore, which implies k equal to 2. Next, we have to find the probability of x greater than 0.5. Therefore, we are using the same property and above property integral minus infinity to plus infinity f of x dx. Here the limits we are updating it as, since x is greater than 0.5, we are taking the limits from 0.5 to 1. Integral 0.5 to 1 kx dx, since f of x is equal to kx. Substituting that, integral 0.5 to 1 kx dx. That is k into x square by 2 within the limits 0.5 to 1. That is k by 2 into 1 square minus 0.5 square. Substituting the value of k, which is 2 by 2 into 1 minus 0.25. 2 by 2 is 1 and 1 minus 0.25 is 0.75. And this is the probability, 0.75. Thank you.